Hello children. Now in this video we will be discussing the details of processes of extraction of metals. Now first we will know what is metallurgy. The definition is the process used for extraction of metals in their pure form from their ores is referred to as metallurgy. Metallurgy deals with the production and purification of metals and manufacturing of alloys. So the steps for extraction of metals from ores. Now these steps are consisting of crushing and grinding of the ore, then concentration or dressing or beneficiation of the ore, conversion of concentrated ore into oxide either by roasting or calcination, then reduction of metallic oxides which is also called smelting, and then refining or purification of metals. So we will again repeat: crushing and grinding, concentration or dressing or benefaction, conversion of concentrated ore into oxide by the process of roasting or calcination, then reduction of metallic oxide or smelting, and then refining or purification. This is a flow chart: ore, crushing and grinding, concentration. Now concentration can be done by four methods: either gravity separation, froth flotation, or magnetic separation, chemical method, or leaching. These methods apply for different ores. Then after concentration, roasting and calcination. Then reduction. Reduction can be of two types: chemical reduction and electrolytic reduction. Then refining, and finally we will get the pure metal. Now ores are crushed into fine powder in a big jaw crusher and ball mills, and the process is called pulverization. Now some important definitions like minerals and ores. Minerals are naturally occurring compounds of metals and which are generally mixed with other substances like soil, mud, sand, silica, limestone, rocks, etc. And these earthly impurities, that is soil, mud, sand, silica, limestone, rocks, these are called gangue or matrix. Now ores are those minerals from which metals are extracted commercially at a comparatively lower cost and with minimum effort. So ores are some specific minerals. So all minerals are not ores. Ores are those minerals from which you can get the metals. So all ores are minerals, but all minerals are not ores. Some specific minerals are ores. Other definitions like charge: mixture of materials fed into a furnace. Furnace is a big, you can say, big place, big container in which you can heat certain material. It's a big reactor to extract a metal. So the mixture of materials fed into the furnace to extract the metal is called charge. Because if you want to extract the metal, you don't just put the metal inside a furnace, heat it, because the furnace can be heated at very high temperature because you require that high temperature to extract the metal. So no, not that. Along with metal you have to add certain other things to react so that the metal can be extracted. So that is called that charge. Now gangue. Gangue already we have seen. Gangue or matrix, that is that impurities like rocky impurities like SiO2 etc., or earthy impurities, sand etc., silica, mud etc., all these are called gangue. These are present in an ore because ore you are getting from the earth. Next is flux. Substances added to get rid of the gangue. How to get the gangue separate? Ore and the gangue should be separated. So some substances are used, those are called flux. Then slag. The flux and the gangue is mixed up and that is called slag. So the step 1 is concentration of ore. we have discussed the first one, that is ore is crushed. After crushing etc., we are getting some powder, fine powder. Then we go for the concentration. Now concentration of ore is a set of processes used to remove as much as gangue as possible and is known as the concentration of ore. It is also called ore dressing, and the purified ore is called concentrated ore. Now concentration of the crushed ore is generally done by certain methods we have already mentioned, that is gravity separation or hydraulic washing. Gravity separation is also called hydraulic washing or levitation, then froth flotation, then magnetic separation, and chemical method or leaching. Now what is gravity separation? This makes the use of differences in the densities and the gangue, and this is the principle of this process. Ore is well crushed, placed on a corrugated vibrating table. This is the table, corrugated vibrating table. The ore is poured over this sloping vibrated corrugated table with grooves. These are having some grooves, and a jet of water is allowed to flow over it. The denser ore particles settles down in the grooves. The denser particles are shown over here. The denser particles are settled down in the grooves, and lighter gangue particles are washed down by water. That is also shown that lighter particle is with the water. Oxide ores of iron and tin are generally concentrated by this method. Oxide ores means like SnO2, Fe3O4 etc. are concentrated by this. There is a YouTube video link is also given for you. If you wish, you can see this link. Then you have froth flotation. I have given you two figures for understanding the process. This is the process which depends on the preferential weightability of the ore with the pine oil. You can see the whole thing, you will be able to understand what is happening. So this is the process which is depending on the preferential weightability of the ore with the oil, especially pine oil is taken, and the gangue particles by water. What is done? The crushed ore is taken in a big tank containing pine oil and water. Then potassium ethyl xanthate is added to it. Potassium ethyl xanthate is added to it. A current of compressed air is also passed. A current of compressed air is also passed. The whole mass is agitated, means stirring. There is a stirring with a high speed, that is agitated. The ore is weighted by the oil. You can see here very well, the ore is weighted with the oil and gets separated from the gangue. Now gangue is at the bottom. You can see here gangue is on the bottom. Here also you can see. These two diagrams are given for better understanding along with the YouTube video link. So the ore is weighted by the oil and gets separated from the gangue in the form of froth. F-R-O-T-H. Now the impurities get weighted by water and remain behind in the tank. Since the ore is lighter, it comes on the surface with the froth. It comes on the surface. It is the surface with the froth. And impurities are left behind. That means here. Now this process is generally conducted for sulfide ores like zinc blende, galena. Zinc blende is Zn zinc sulfide, galena is lead sulfide, and lighter than the impurities present. They are concentrated by froth flotation process. Then third is electromagnetic separation, or generally you can say magnetic separation. Here also I have given some YouTube video which you can see. Crushed ore are generally placed over a conveyor belt. Now the principle of this process is magnetic properties of the ore. Now this conveyor belt rotates around two metal wheels. one of which is magnetic. See, one which is shown magnetic wheel, another which is wheel is shown non-magnetic. Magnetic particles are attracted to the magnetic wheel and fully separated from the non-magnetic particles. This is generally used to concentrate tin stone, that is stannous oxide. It contains magnetic oxide, that is iron, as impurity. Then you have chemical method or leaching. In this the ore is treated with a suitable agent like acid, base or any other agent, so that the ore is soluble in it but the impurities are not. Then the impurities are removed by the filtration. Solution of the ore, that is the filtrate, will then treated with the suitable reagent which will precipitate the ore. Now we will be discussing this in detail in the extraction of aluminium. Leaching method is generally used for concentration of metals like silver, gold as well as aluminium. The ore, even after concentration, contains some impurities or gangue. To remove these gangue, certain substances called flux, which we have already discussed, these are mixed with the concentrated ore. Now the added flux combines with the gangue to form a fusible mass which is called slag. Slag is generally lighter and floats on the surface of the molten metal, so it can be removed very easily. Then conversion of concentrated ore to metal oxide. Most of the metal ores are carbonates or sulfides or hydrated oxides. These are converted to their oxides as to reduce them easily. So following two processes are generally used. One is calcination, another is roasting. So we will first do the calcination. It is the process of heating the ore to a high temperature in absence of air. Now here the air doesn't take place in the reaction. Usually carbonate ores or ores containing water are calcined. During calcination, certain processes certain changes take place, like moisture is removed, volatile impurities are removed, carbonate ore is changed to oxide, entire mass becomes porous, which helps in the reduction. So here zinc carbonate to zinc oxide and aluminium oxide to aluminium oxide plus 2 water, means water you can remove. You can have calcium carbonate also. If you heat calcium carbonate, that also can be converted into calcium oxide and carbon dioxide. Now roasting. Roasting is the process of heating the concentrated ore in the presence of air to a high temperature, but it should not melt. This is generally employed in the case of sulfide ores or the ores containing metallic sulfides as an impurity. During roasting, following changes take place, like it removes moisture or water from the ore, expels out or burns the volatile impurities like sulfur, phosphorus, arsenic, etc. The ore becomes porous and converts sulfide ores to oxide ores. Now sulfur, phosphorus, arsenic, these are generally removed as sulfur dioxide, phosphorus pentoxide and arsenic trioxide. Metallic sulfides are reduced to the respective oxides and there is a generation of sulfur dioxide gas. So this is the comparison between calcination and roasting. Then step 3, that is reduction of metal oxides to metals. After roasting or calcination, the metal oxide is reduced by heating it with reducing agents like carbon, carbon monoxide. Carbon is in the form of coke, carbon monoxide or hydrogen to get the crude metal. Selection of reducing agent will depend on the position of the metal in the reactivity series. So the reactivity series is shown over here. The metals are shown, method of reduction of their oxide. For the case of potassium, sodium, calcium, magnesium, we have to go for electrolytic reduction. These cannot be reduced by coke or carbon monoxide. For aluminium, zinc, iron, lead, etc., carbon reduction is taking place. Zinc oxide with carbon will give you zinc and carbon monoxide. Here also for copper, iron also the same is taking place. Mercury, silver, platinum, iron. Now mercury and silver oxides decompose by heating only, and platinum and aurum, they do not form oxides. So this is the activity series where reduction of metallic oxides based on the activity series. Now activity series we had already discussed. Here the metal potassium is generally kept at the top. Before it there is lithium, because it is the most reactive one and most electropositive, as it is easily oxidized, that is it can give a valence electrons. If you refer periodic table again, so you will be finding it gives a valence electron very easily. Least reactive is gold, which is placed at the bottom of the list. Hydrogen is also placed because we had already discussed in the previous videos that hydrogen, though non-metal, is included in this series because it can form the positive ion. Now hydrogen occupies a position between lead and copper based on its reactivity as compared to the other metals in the series. The main points in the activity series: any metal higher up in the series displaces any metal below from the salt solution of the latter. The larger the difference in the positions of the metals in the series, more rapidly does the displacement occur. Metals above hydrogen may displace hydrogen from water and from dilute acid, but the metals below hydrogen cannot. Oxides of metals like potassium, sodium, calcium, magnesium and aluminium cannot be reduced by hydrogen, carbon monoxide or carbon in the form of coke. Oxides and nitrates of mercury, silver and gold, they decompose to give the metals on being strongly heated. Metals below copper, these do not rust very easily. Now this activity series is generally based on the reactivity of metals towards acid, air or water. Position of some elements may be different than electrochemical series, which is based on the tendency to lose valence electrons, that is electromotive force. That also we had discussed. Now, oxides of highly active metals like sodium, potassium, calcium, magnesium and aluminium have great affinity towards oxygen. So, it cannot be reduced by common reducing agents. Their metals are obtained by electrolytic reduction or fused metallic salts, halides or oxides using inert electrodes. Now, inert cathode is generally made of iron and anode of graphite. You can see the reactions over here. Electrolyte is a fused potassium bromide, you can get potassium and bromide. Fused sodium chloride, you can get sodium and chlorine. For calcium also, this is happening. Fused calcium chloride, you can use, you will get calcium and chlorine. So, reactive metals cannot be extracted from their aqueous solutions by electrolysis, as they can react with water. Aluminium is obtained from its oxide by electrolysis. Metals in the middle of the reactivity series, which are there, zinc, iron, lead, copper, etc. These are moderately reactive. They are usually present as sulfides or carbonates. Now sulfides will be undergo roasting and carbonates will undergo calcination, and both will give oxides from the sulfide and carbonate respectively. Metal oxides then reduced by suitable reducing agent, which is called carbon reduction process. Zinc oxide and coke are heated over here around 1400 degrees Celsius. You will get zinc, which is called zinc spelter. Zinc oxide cannot be reduced by carbon monoxide or hydrogen, as they are unable to overcome the affinity of zinc towards oxygen. So zinc oxide is reduced only by heating with carbon, which is a very strong reducing agent as compared to carbon monoxide and hydrogen. Iron, lead, copper, these can be obtained by reduction of their oxides with carbon, carbon monoxide and hydrogen. But in case of zinc, zinc oxide can only react with coke at very high temperature. Highly reactive metals can be used as reducing agents because they can displace metals of lower reactivity from their compounds. If you want to get manganese, its oxide is heated with aluminium powder. Aluminium being metal is very powerful reducing agent. When mixture of aluminium powder and iron oxide is ignited, latter is reduced to metal, means iron oxide is reduced to iron. This is called aluminothermy. This displacement reaction is very exothermic, very highly exothermic, and amount of heat evolved produces metals in the molten state. Metals low in the reactivity series are very less reactive, like mercury, copper, etc. These oxides of these metals can be reduced to metals by heating alone, like mercuric sulfide. If you have that, which is cinnabar, when it reacts with oxygen, it will be converted into oxide. Mercuric oxide at about 300 degrees Celsius will give you mercury and oxygen. This type of reaction we had already gone through in physical and chemical changes chapter in respectively class 7 and 8 respectively. Silver oxide, same, if you heat it around 300 degrees Celsius, you will get silver and oxygen. Copper, which is found in nature as copper sulfide, can be obtained from its ore by just heating in air. So copper sulfide will give you copper oxide. Copper oxide again along with copper sulfide will give copper and sulfur dioxide. Now this method is known as auto reduction process. This method, that copper sulfide is first converted into copper oxide and then copper oxide is reacted with copper sulfide to give you copper plus sulfur dioxide. This is called auto reduction process. Silver is obtained by displacement from solutions containing its ions by more electropositive metal like zinc. Any solution you can take of silver, and if it reacts with zinc, zinc will get an ion from silver and silver will be deposited. Next is refining of metal. It is the separation of the above extracted metal from the residual impurity. So whatever we have got in the previous section, those are crude one. So now you have to do the refining. So now you may have some residual impurities which may be due to the presence of other metals and non-metals like silicon and phosphorus, unreduced oxides and sulfides of the metal. So refining is the process by which crude metal is purified. Method of purification will be dependent on nature of the metal, nature of the impurities present in the metal, and what is the purpose for which the metal will be used. So the methods can be, one is distillation. If you have the metals like mercury and zinc, these are volatile. They will distill over in pure form and the non-volatile impurities will be remain behind. Zinc spelter, that is that zinc we have got in the previous section I had shown you. That zinc oxide plus carbon gives you zinc spelter. So zinc spelter on distillation will give you pure zinc. Then you have liquefaction. Metals like lead and tin which have low melting point They are heated on a sloping hearth of a furnace. This is impure metal you are putting. Infusible impurities are coming. Pure metal you are getting the slope over there. The molten or fused metal flows away, leaving behind the impurities. So you are collecting the pure metal over here. Then the last point is electrorefining, which we had discussed in detail in electrolysis chapter. There you are having electrolytic cell, two conducting electrodes. We had already discussed in the electrolysis chapter that refining. Electrolyte is generally used the salt solution of the metal, which is generally to be refined. Little H2SO4 is added to increase the conductance. Electrodes suspended in the solution of electrolyte. If you pass the electric current, metal ion will be reduced to metal. Equivalent mass of anode will dissolve. Anode will have the same metal. Equivalent mass of anode dissolves from the anode and goes into the solution as metal ion. So M is the anode, which is M is the metal which is need to be refined. Pure metal then deposit at the cathode and impurities will be settled down as a anode mud. Metals like copper, silver, gold, nickel, aluminium and zinc are generally refined by this process. We had discussed electrorefining of copper in the electrolysis chapter in detail. Now single electrolytic cell can be scaled up to include multiple electrodes at an industrial level. This is the summary of the steps involved in extraction of metal from its ore. Thank you for patience hearing.